Today's speaker is Mike Meridith, the Senior Director of IT at VictorOps. Ladies and gentlemen, please put your hands together for Mike.
Thanks, everybody. And I just want to take a moment here and say thanks to the team at Nagios. This is another great conference. It's my second time here, and I think it's awesome, you know, both for the resources that Nagios is providing, and for for all of you coming here. It's just a great crowd that comes for this show. So I'm really happy to be here. This is going to be a less technical, more kind of cultural talk about DevOps. I'm Mike Meridith. I'm the Senior Director of IT at VictorOps, and we're out of Boulder, Colorado. And working at VictorOps over the past few years has really been an incredible opportunity for me. I'm helping to build a great product, and it's in an environment that encourages experimentation, collaboration, and creative problem solving. And for us, that means aligning around DevOps principles and sharing responsibilities. I wanted to share some of what I've learned in that environment as it applies to monitoring and especially, of course, to Nagios. Really, it's a talk about how you can use Nagios and Nagios management as a way to help transition into a DevOps alignment and to start building the processes and the relationships that you'll really need to make that work. So it's probably not necessary to dive too deep into what is DevOps, and talk around DevOps is kind of getting cliched, and I don't like to be too doctrinaire about these kind of things anyway. Discussion around what workflow or what ceremony or whatever you need in order to be truly DevOps, I think totally misses the point. It's really just an alignment of goals and a lowering of walls between groups in an organization. Generally, we're talking about developers and ops people, and the big novel idea here is just sort of not incentivizing these teams to act like rival gangs. Instead, you put operations on the hook for delivering product. You put developers on the hook for platform uptime. In other words, the goals of each team become the goals of both teams, whatever that means for your organization. And it can and should also include your product team, your marketing team, your sales team, everyone. But really, we're going to focus on the technical side of the house. So for our purposes, we're just going to be talking about software development and platform operations working together as a single team. For us at VictorOps, it means a few specific things. For the IT engineers, it means adopting workflows that are more familiar to developers. Infrastructure as code is kind of a highfalutin term, and again, it kind of invites unhelpful doctrine to talk about it, but it's an important concept. It applies to systems management frameworks like Puppet and Chef, but also to tools like Canonical's Juju or Metal as a Service, even down to DNS databases, right? They allow us to describe how we want our infrastructure to look and function, essentially in source code. If we treat the configuration of our infrastructure as source code, write it, test it, and deploy it using software development workflows, then suddenly we can deal with much larger and more complex infrastructure. Backup and restore takes on different dimensions and becomes much more manageable. Environments become reproducible, which is kind of an amazing thing if you've been at this for a while like I have. And the source code becomes living documentation that can help new employees understand how everything works together. On the development side, it means developers participating in operations, specifically taking on-call shifts and working the front lines of platform reliability. At VictorOps, this is particularly valuable since it's related to what we actually do, and it means our developers are using our product on a day-to-day basis, gaining a better understanding of how our customers get value from us, and experiencing firsthand, when a minor UI tweak, for example, might provide a huge usability improvement. It also builds empathy between development and IT, and this benefit could apply really in just about any company. If a developer deploys a long-running process that crashes every day at 3 a.m., then they have to live with the consequences along with everybody else. The advantage here is obvious, right? Their reaction changes from, just restart it. Why are you complaining to, wow, I better fix that process. Of course, you can't just throw a pager at a developer and wish them luck. Just as IT people are picking up development tools and techniques, developers have to learn some of the operations tool set. So as an ops person, right, I think Nagios is a natural place to start when introducing developers to platform management. Not only is it one of the main tools that you turn to in a crisis, it's a valuable way to visualize a running platform at any time. It's stateful. That's important. A lot of developers that I meet come into the world of operations thinking about monitoring in a totally kind of event-driven way. They're used to interacting with software via log files and debug output, so it's natural to think, hey, if there's a problem with the software, it'll show up in the logs and we can send an alert on that. And that's fine, that's great, but it misses the benefits of stateful functional monitoring. Okay, so an error condition occurred, good to know, but what's the status of the platform right now, Are things working? Are our customers able to connect? An event-driven approach also assumes you can correlate every error condition to a message in a log file, but that's not always true, and that's not always the easiest way to detect an error condition. Exposing developers to Nagios early helps them understand the importance of state in platform management. It helps them write better checks, which reduce noise for everyone supporting the platform, and ultimately leads to better code and better products. Now, that doesn't mean everybody in the pool, right, when it comes to managing a Nagios config. One of Nagios' key strengths, and I think Ethan referred to this morning, is the flexibility of the configuration language and its ability to meet different needs in different ways. I really appreciate, not being shoehorned into a single approach to configuration, and I wish more software put a value on that, honestly. And the downside is that the flexibility can lead to ambiguity in the running config, especially if multiple people are maintaining the configuration, and especially if they're accustomed to different conventions. This can make it hard to read the configuration, hard to debug it, and hard to modify it without causing unintended problems. But we want everybody in there making continuous improvements, right? So how do we enable that without creating spaghetti config? I've got a few strategies to share that may be helpful. First of all, source code management is absolute table stakes. If you can accomplish nothing else, get your Nagios config under source control management. All you really need is Git and a few shell scripts to make a workable system. You can get this working in a couple of hours, and there's really just no reason not to do it. If all you have is your config and source control and some shell scripts to check it out and install it, you still have a powerful tool at your disposal. You can run a Jenkins instance on your Nagios server and automatically detect new commits and install them. You can adopt a pull request workflow this way with nothing more than that. Channeling changes through pull requests allows a single maintainer to vet and approve all of your configuration changes. Submitters see what changes were necessary to their code and learn to make better code and to stay consistent. Pull requests are great teaching tools in this way. Most of your Git management tools like GitHub have conversational tools built into the pull request flow. So when you get a minute, you can go and look at your list of pull requests, and you can add comments for, hey, this needs to be done in a different way, or I had to make the following changes. People learn then by doing, and the worst errors get caught before they can cause a problem in production. Using a systems management framework really takes it to the next level. And this is where infrastructure as code really takes shape. It doesn't really matter what framework or application you use, CF Engine, Puppet, Chef, Ansible, bunch of shell scripts. All of them have advantages and disadvantages, and you'll just have to figure out what's going to work best for your organization. Now, if your organization doesn't already have systems management frameworks in place, it's actually a great opportunity to collaborate with your development team and find a solution that's going to make everybody happy. For example, at VictorOps, when I came in, I was a big CF Engine guy. That was pretty much everything I knew in systems management. But the developers were all familiar with Chef, and they weren't happy with the purely declarative DSL of CF Engine and I didn't like the idea of the purely imperative DSL of Chef. So we talked around it for a while, and we kind of found a halfway point with Puppet. And I think we really kind of all came out of it with a feeling like, we're communicating with each other, and we're really ready to kind of collaborate and work together. It was a way for me and them to both demonstrate, that we can compromise and find solutions that are going to work for the larger team. Anyway, the point is, any of these frameworks will provide huge benefits, like catching config errors, even abstracting configuration objects in such a way that people can contribute configuration without having to understand all of the intricacies of Nagios configuration. A good systems management framework can even build a lot of your Nagios configuration automatically based on what your systems are reporting in. I actually did a talk here last year about using Puppet in this way. I think you can look it up on the Nagios site. And I think it's a great approach. You're accomplishing a lot more with less work and with more people able to contribute. And getting computers to do some of the tedious configuration work that humans are prone to messing up, with typos and so on, is a great way to prevent human error. Again, you use a pull request-based workflow with your source control management to ensure that everything gets error checked and vetted. Another helpful tool that we use at VictorOps is runbooks. These can take the form of articles in a wiki or shared documents folder or whatever, as long as it's available to everyone. It's not a new concept at all, but what's important here is to make sure that everybody on the DevOps team can get to the runbooks, can read them, and can contribute to them. Publish templates and set standards for what information should be in a runbook and how it should be organized, and it will help people to contribute. Some people don't see a need for runbooks. They just want to tell everybody to read the manual and figure things out. Read the freaking manual is a fun thing to say to a new user that's asking a stupid question, but it's maybe a little less helpful than you might think. And the honest truth is that most everyday users of complex software like Nagios don't have to know every nuance. They just need to know what to do right now in order to solve the particular problem that they're having today. So runbooks are a great way of documenting little procedures and recording any site-specific things that you're doing in your environment, like how to acknowledge an alert, how to set up a downtime or disable alerting globally, that sort of thing. Your organization is going to have your way of doing that, and it's best that people learn kind of the organizational way. I think I've also found that writing runbooks is a great way to check procedures, kind of for sanity as you're describing them. Recently, I got about halfway through a runbook. I was describing how to set up a replication for our MySQL environment, and I was about halfway done, and I said, wow, I would not want anybody to attempt this process. This is just insane, right? And that's a sign that you need to tune up the process and that you're doing something that's dangerous or difficult to reproduce. And that's, you can't have that in a DevOps environment. An important detail when writing a runbook is don't assume prerequisite knowledge, but reference it. Provide links to the official documentation, and you can help people learn to fish, right? It's not a bad idea, for example, to write a Reading the Nagios documentation runbook for your organization. The official Nagios documentation is great. It will answer just about any question you might have, but it can be a little bit hard to find the right reference if you don't know the basics. A few signposts can help new users get more efficient with the official documentation, and then, read the freaking manual stings a bit less if it's expressed as read this entry on this page, and it's going to solve this particular problem that you're having. Okay, so you've built a pipeline for config changes, you've published some runbooks, you've given all the junior developers the keys to your Nagios configs. Nice secure feeling, right? Just sleeping like a lamb at night. Or maybe you might feel a wee bit concerned about all the untrained newbies checking in changes to your lovingly hand-built Nagios config. Of course, you have to protect your running Nagios instance. You can't allow a typo to take out your monitoring and cause you to miss an outage. In addition to that, a pull request-based workflow can only scale so far. Eventually, you need multiple maintainers, And someday, you're going to have to bow to the reality of giving a lot of people the ability to commit. And anyway, you can't count on yourself to catch every error that appears in a pull request. Luckily, Nagios has a built-in config validator that can be called before you push a new config. Other tools, like maybe Nagios, could be used to do statistical analysis in case you want to throw alarm if the number of config objects suddenly triples in your Nagios config, or suddenly goes down to 5% of what it was. Combining tools like this in your Jenkins pipeline can help you sleep at night by assuring you that the most obvious and common mistakes will get caught before they go near production. It kind of goes to an important topic that comes up a lot when people talk about DevOps, and that's the idea of a blameless culture or doing blameless postmortems, right? The idea is that recrimination and anger have no place in a postmortem meeting. Everyone should feel free to talk openly about whatever actions that they took around an incident without the fear of getting yelled at or blamed for an outage or a bug, right? It's about solving a problem, not focusing on who caused it. We practice that at VictorOps, and it doesn't just make postmortems more pleasant, it makes us better technically because people really are more comfortable sharing information. It's true, it works, but it's a delicate balance, and you have to keep that kind of blameless thought in the front of your mind sometimes, especially when a problem was clearly caused by an egregious screw-up, right? Sometimes somebody screws up and it causes a problem. So the best way to keep a blameless culture going is to make it harder for people to screw up, right? Or to put it more blamelessly, if you like, if people are making mistakes, there's a problem with the process, and that's not the fault of the person that made the mistake. They did you a favor by drawing attention to the process weakness. And that's a very Zen statement, but you have to internalize that, and you have to keep that in mind. Put up some guardrails, and you don't have to test your dedication to blameless culture every day, right? Now, no config validator script can predict every kind of error, so it's important to have a quick rollback strategy, hopefully one that can get called as a single script or a single command, right? Your config is under source control. Well, great, no problem. You revert the last commit and roll the config back out, you're back up and running. If you're in a management framework, it can get a little more complicated. Sometimes you need to figure out a whole new policy to correct an issue, and in the meantime, you have no monitoring. A trick I use is to script a backup of the current config directory whenever a new config gets pushed by my systems management system. That way, if the shit really hits the fan, I can just shut down the Puppet agent on my Nagios server, move a directory back in place, restart Nagios, boom, I'm back in my last known good state. Again, it's about sleeping better at night. It's well worth a little tiny time investment that it takes to get something like that going. Of course, you can't roll back unless you know there's a problem. If Nagios isn't doing its job, or if it's lying on the ground twitching and drooling, how do you detect it? A simple solution, obviously, is to fire up a second Nagios instance, preferably running somewhere else. Fire up an EC2 instance or a VM at SoftLayer or something like that. You can have it log into your VPN if you don't want your main Nagios server on a public IP. Another alternative is an external monitoring service like Pingdom or Site24/7. Those types of services are pretty damn expensive to use as a main monitoring solution, but they're great at doing one or two simple checks. The easiest approach for this is a quick content check, right? If it can log into the system and it sees the word Nagios, then great. At least Nagios is running. A more advanced approach would be to log in and maybe check the number of services in an unknown state, or to again look for big changes in the number of hosts or in the number of services being monitored. That way you can catch not only errors that cause total failure, but those that cause big unintended changes in your monitoring. Another important way of making it harder to screw up is to modularize the configuration as much as possible and use templates as much as possible. The less work somebody has to do to get a host or a service defined, then the less likely they are to make an error. In a perfect world, Someone should be able to define a host with an FQDN and maybe a host group or two and have 99% of their work done getting the host monitored. Host groups are great because you can declare membership within a host definition or with a glob in the host group definition. Big bucket host groups like production and staging pardon me, allow you to broadly apply things like time periods and alert destinations, and host groups called out in host definition, like say, MySQL servers, can be associated with more specific services. If your host groups are well defined and your services are associated with host groups rather than hosts, then adding a new host to monitoring becomes very simple, very hard to mess up. If you get things that buttoned down, then documenting the process for adding hosts and services becomes easy, right? Writing those runbooks becomes easy. From there, you can use submodules in Git as a way to create sandboxes where people in different disciplines can add chunks of config without stepping on one another. A submodule can populate a Nagios config directory and stay well away from the main config file. Okay, a lot of the advice that you've heard really amounts to practicing empathy with developers. Again, that's really what DevOps is all about, trying to align yourself with your coworkers. Look for other opportunities to provide comfort to your developer friends. For example, I maintain a Vagrant environment that developers can fire up to test config changes before submitting a pull request. It gives them a familiar way to try things out, and the exercise has improved my own processes, taught me to do things in new ways that allow me to get more done more safely. As an ops person, you may not be used to thinking about code styling, but a lot of developers care about it a lot, and for good reason. Well-styled code helps comprehension. If your developers that you work with are giving you feedback about code style, listen to it. If you can adopt mutual standards, that gives you a leg up on understanding the code that they're writing too. We spend a lot of time talking about this stuff at VictorOps because it produces real results. We are able to get a lot done while running pretty lean because we keep the walls down. And that's a continuous, iterative process that takes conscious effort and constant communication. We have process retrospectives at least once a month or so where we just make sure that we're still on track and we're still communicating and we're still operating as a single team and we're still aligned. You have to keep that up, but it's worth it. Everybody wins when you let developers into the infrastructure stack, and especially the Nagios config. As an ops person, you get to keep using the tools you love rather than fending off rogue IT. If you don't let developers into your monitoring, it's not that they're going to live without it, they're going to set something else up. And then one day you may find that that's the main monitoring tool at your organization. You didn't get to pick it. Developers get a better understanding of the needs of the ops team this way, and they can develop for them more effectively. The combined team will write better monitoring checks and be motivated to write better code that can be monitored more easily. I hope this has been helpful and given you some ideas about how you can use Nagios to help create a bridge between dev and ops. It's been a pretty short talk, but I'd be happy to answer any questions that you might have. Thank you.
Thank you, Mike. Anyone with any questions, feel free to put your hand up. I'll come around.
So you've mentioned using Git for source control, which is good. I'm wondering about your policy as to when do you tag, when do you branch, and so forth, or do you just use master and revert back to a certain commit?
For a long time, I just worked exclusively out of master because I was a one-person IT department. At this point, I encourage people to, make a branch if they're working on something more than just a trivial change and submit a pull request for that. But if it's, if you're changing one line in a file somewhere, usually we just check that into master.
And a follow-up question.
Yeah.
Once the code is committed, how often is it reloaded by Puppet?
Well, we've got a Jenkins process that checks the repository every 5 minutes. And if it sees that there's been a commit, it will check that out and it'll run, some delinting and parser checks on that, and then push it out to the Puppet master. So every 5 minutes.
And is that first push to some testing Nagios instance or directly into production?
It should go into testing first. Someday it will.
Awesome, good session.
Thank you.
Thank you, Julie.
Hi. Yeah, we have runbooks, and nobody likes them.
Yeah.
Okay. I noticed that our company started runbooks, and we try to document everything in the runbook, and runbook gets very large. Okay. Nobody wants to wake up in 3 o'clock in the morning and look at 500-page runbook and find the text where you're supposed to fix it. So we implemented something called Wiki. So you can actually search on the text that you're looking for. With that, that's like our operational guide instead of runbook just contains the installation. However, the wiki contains the operational how to fix. I think that might be a better method.
Yeah, I mean, being searchable is great. Another thing that we do at VictorOps, because it's built into our tool, is that when an alert comes through, we add an annotation to that alert saying, hey, the runbook for fixing this kind of problem is here, and you just click on a link, and there's the right page with the references for what you need to do.
Yeah, we have for help desk, we have the link on how to fix the problem. But whenever the Nagios itself has some kind of issue, for Nagios, we have a wiki for our Nagios instance. For help desk, we do have the link to the wiki to help them fix their problem. I mean, it's similar, but
Yeah.
I don't know. Runbooks, we implemented it. Our CIO did, but oh my God.
Thank you. Anyone else with any other questions for Mike? Sure.
Hi, thanks for the good talk.
Thank you.
I was kind of curious, you mentioned some scripts that you have for your Git commits and hooks and things like that. Is there any of that for available to the community, or is that all developed in-house? And I don't want to reinvent the wheel, right? So it seems like you guys have a great solution. Is there anything that you know of out there in the exchange or whatever?
I mean, if you look up my talk from last year, I actually published to GitHub some Puppet policy that I wrote for kind of automatically generating your Nagios config, based on your clients checking in, and that has kind of the little scripted method for moving your config to a backup location before it installs the new config, and running the parser before you install it and making sure that it's going to work. So that's on GitHub. I think it's github.com/victorops/puppet-nagios, I want to say. It might be nagios-puppet.
It's in that talk from last year?
Sorry?
It's in that talk from last year?
Yeah, it's in the talk from last year.
Cool.
Love your T-shirt.
Oh, thanks.
Thank you.
You mentioned, or how do you go about working with your development teams? You mentioned maybe once a month you have a keep up to date, but do you do more than that? And some people use the agile function, or do you use your Jenkins to post projects, and just how do you keep in touch because the fast-paced movement of development of applications?
Yeah, they work in sprints using Atlassian Jira, and for a long time I actually just worked in sprints with them and added IT stories to that. But recently I kind of realized that wasn't making a lot of sense because it's IT work, and so you're not building towards a big release. So I'm still in Jira, but I changed all of the IT tasks over to a Kanban board, and so I'm still working collaboratively with them. They can still create issues for me and track the process of issues going on. I can still move issues over to their workflow and track the progress. But it allows me to kind of do a workflow that makes more sense for IT work. They can still do sprints and releases because that makes sense for them.
Sorry, one more. And have you gotten to the point where they're monitoring, where you can actually go in and run checks to test things in their application, like log in and run an instance, and then depending on, I don't know what the applications you're developing, but
Yeah. It's a web application, and so
Okay.
there's a lot of potential for that sort of thing. And we've done a bit of that. We have fairly complicated scripts, that will test out, pieces of our platform. It's a notification platform, so we'll, send an SMS out and make sure that it arrived at its destination, and then report back the results of that kind of statefully to our Nagios server. And that's, almost all of that effort is coming out of the developers because they're the ones that know, first of all, the API hooks into the system and, the best way to kind of exercise all of their little actors in a way that it's really going to kind of uncover what the real problem is if it throws an alert. And that's something that we kind of go back and forth on a lot. It's, every time you have an outage that you weren't expecting, somebody says, what are the 5 things that we need to monitor now that we weren't monitoring before? Okay, and so we'll, add a bunch of monitoring checks, and of those 5, maybe one of them will be actually actionable, right? And so we'll, kind of go back from that and say, okay, great, I see from Nagios that MySQL has some long-running queries going. What the hell does that mean? What am I supposed to do about that? And that, gives them the feedback to say, all right, I need to write a better check. That's, okay, I care about long-running queries, but why? So why don't I go test that thing that I care about instead, rather than, kind of these little meta issues that aren't always directly related.
Any other further questions for Mike?
Sorry, got one more. You've mentioned parsing for errors. Do you just use the Nagios -v flag and then you look for the return code and parse the output, or what do you do exactly?
Yeah, exactly. Basically, the 10-cent version of that is you run the Nagios -v, and if it exits with a 0, then you can at least install the config, and Nagios will be running at the end of it, so you can, log in and see what happened.
All right.
Anyone else? Mike, do you have any upcoming projects or anything you're currently working on that you'd like to share with us?
Well, I'll just reference it again. The Puppet Nagios project that I presented on last year. It's on GitHub, and it's a public project. I would love to see some collaboration. It doesn't do that much. I would love to see it doing more. So if anybody feels like they've got free time coming out of their ears, I would love to see some contributions to that. It's called Puppet Nagios. I think it's github.com/VictorOps/Puppet Nagios. All right. Thanks, everybody, for your time.
Thank you, Mike.